Let's do Mastery Items Week 8C. Question number 1. Factor the following polynomials. This is from Chapter 3. You should take a look at each one of these polynomials and notice right away that they are a difference, there's a subtraction sign in the middle, of squares, x squared and 100. And there's always a common pattern when factoring a difference of squares. We're going to end up with two factors, two binomial factors. One will be a plus factor, one will be a minus factor. Our first term is just the square root of the first term of our polynomial. So the first term of each binomial in our answer is the square root of the first term in the question. So the square root of x squared is x. The second term is simply the square root of the second term. Square root of 100 is 10. So x squared minus 100 is equal to x plus 10 and x minus 10. Question B, same thing. It's a difference of squares. So we create our two binomials for our solution. And one is plus, one is minus. We square root the x squared to get x for the first term. We square root the 36 to get 6 for our next term. Letter C. This one is also a difference of squares. Although, what you need to do first in this one is factor out a greatest common factor. Both of these can have a 4 factored out first. We should always factor out greatest common factors first. Then our x squared minus 4y squared is a difference of squares. So we keep our 4 on the outside, and then we write down our plus and minus. X will come first, because the square root of x squared is x. Then the square root of 4y squared is 2y. So it'll be plus 2y minus 2y. And that is our solution. Letter D. That has a 4 on it, a power of 4, but it's still a perfect square. So it's still a difference of squares, so we're going to have a plus and minus. And the square root of x to the power of 4 is x squared. We divide it by 2. So it'll be x squared plus 2 and x squared minus 2. Now we should check to see if this is a difference of squares here, because our first term is a square. We have a subtraction sign, but our second term is not a perfect square, so we will not be able to factor that one down. All right, let's move on to question number 2. Simplify the following square roots. We're going to do the same process as we did in week 8B. Let's list out some perfect squares. 1, 4, 9, 16, 25, ... Those are our perfect squares. We take 8, and can we divide it by one of these perfect squares? We can. We can divide it by 4. So the square root of 8 is equal to the square root of 4 times 2. Then we can separate this to be the square root of 4 times the square root of 2. Now the square root of 4 is an easy number to calculate. It's equal to 2. So we get 2 times the square root of our 2. That is our simplified answer. Simplified means we have the smallest possible whole number under the square root sign. All right, let's look at square root of 12. Again, we can divide it by 4, so it's the square root of 4 times 3. Separate it. Square root of 4 times the square root of 3. Lastly, the square root of 4 is 2, so this becomes 2 square root 3. So 2 times the square root 3 is the same thing as the square root of 12. 16. Oh, take a look. 16 matches right up on our perfect squares, and the square root of 16 is 4. 20. Well, that can be the square root of 4 times 5. Separate it out, the square root of 4 times the square root of 5, and it's equal to 2 square root 5. Question number 3. Build a table of values for the following function for x is an element of this set of numbers, 0, 30, 60, 90, 120. Our function h of x is equal to cosine of x. So we're going to build our table of values, x, and our function evaluated at x, so 0. So our function evaluated at 0 is equal to the cosine of 0. So I go to my calculator, type in 0 cosine, and I get 1. Now make sure your calculator is in degree mode right now. To figure out if your calculator is in degree mode, do sine of 30. If you do sine of 30 and get 0.5, you're in degree mode. So our next one is 30. I do our function evaluated at 30 is equal to cosine of 30. So I put that and I get 0.87. Then I do 60. Our function evaluated at 60 is equal to cosine of 60. 60 cosine is 0.5. Then I'll do our function evaluated at 90. It's equal to cosine of 90. 90 cosine 0. Now I'll do 120. So our function evaluated at 120 is equal to the cosine of 120. And I get negative 0.5. You should start to see some patterns in these charts. And that's how we build a table of values for a function. All right, if you have any questions, please put them in the comments below or contact me. And thank you for watching.